Welcome back. Shown on my screen is the AutoCAD software interface, and it displays the architectural drawing projects that I'll be working on in the course of this training program. The objective of this tutorial is understanding the architectural drawing, the floor plan. The drawing consists of 5 floor plans and a roof plan. The 5 floor plans are the ground floor plan, the first, second, third, and the fourth floor plan. I'm going to zoom and pan around to show you this plan drawing on my screen. Shown on the screen is the ground floor plan. This is the first floor plan. This is the second floor plan, the third floor plan, and the fourth floor plan. We also have the roof floor plan. As shown on the drawing, the roof floor plan is a flat roof and is designed to slope at 5% to this edge of the building. And if we look at the drawing closely, you will see these two lines at the edge of the building. They represent the parapet wall at the edge of the building. It should also be noted that the first, second, and the third floor plans are identical. I will pan back to this drawing to show you this plan. This is the first floor plan. You can see the HOD office, general office, secretary office, lecture room. Same thing here. Same here. Therefore, when we are preparing our general arrangement drawing, the GA, for our structural model, the general arrangement will be the same for the first, second, and the third floor level. Now I will focus on a floor plan drawing. Let me focus on the ground floor plan. So I'll pan to it now. The ground floor plan. The measuring unit used on this project is millimeter. Here you will see the dimension read 5,000, 5,000, 5,000. It means the horizontal distance from this point to this point is 5,000 millimeter or 5 meter. Another example in this is the 7,200 dimension shown here. It means the vertical distance from this point of the grid to this point of the grid is 7,200 millimeter or 7.2 meters. Now I will move to the architectural grid shown on the drawing. The architectural grid are very crucial in an architectural building project because they allow us to reference architectural features such as non-load bearing partition wall in the drawing. In the X direction, the grids are labeled from 1 to 7. 1, 2, 3, 4, 5, 6, 7. Also, they are positioned at the center of the wall feature in the architecture. Let me zoom to it. This grid is positioned at the center of this wall. Same thing here, the grid is positioned at the center of this wall. This grid 2, can see this wall element here. The grid is positioned at the center of the wall. In the Y direction, that is the vertical direction, the grids are labeled from A to F. or sorry, A to E, A, B, C, D, E. And each of these grids are located at the center of the wall elements, of each wall element. As you can see, grid A is located at the center of the wall element. Grid B is also located at the center of the wall elements. I will also use the measure command now to illustrate that all the grids are located at the center of the wall elements. If you click on the utility panel on the ribbon in the Home tab, you click on the measure command, then click on the distant command. Then you move to your drawing and you click 2 points on the wall. For this vertical wall here, if I pick this point to this point, I see that the measurement is 230 mm. So it is shown here that the width of the wall is 230 mm, which is the typical 9-inch block unit type, which is the main block unit used in Nigeria for construction. Now, I would like to take the horizontal distance from this face of the wall to this grid line. I will repeat the last command, which is the measure distance command by pressing the space bar on my keyboard. So I will now click on distance. So I will click this point on the wall to the grid line. As you can see, the measure distance is 115. The 115 mm is equivalent to half of 230 mm. This shows that the grid line lies at the center of the wall in this direction. I will press escape to get out of that command and zoom out. This process can be repeated for other walls. It will be shown that all the grid line lies at the center of the wall if you try it at other location in the drawing. Also, I will draw your attention to the room labels shown on the floor plan. We see here the concrete laboratory, the soil laboratory, the lecture room, and the store. It shows the use of a building is of commercial use. This will guide us in making decisions about the magnitude of imposed load to use in our structural model. The commercial use of the structure means our imposed load will range from 3 kN per meter square to 5 kN per meter square. On the floor plan, we also have elevation labels. We have two types of elevation labels on this floor plan. We have the 0 plus 600 and the 0 plus 445. The 0 plus 600 is located at the concrete laboratory room. It's also located at the soil laboratory room and the lecture room, while the 0 plus 445 is located at the balcony of the structure and also at the staircase area. The 0 plus 600 and the 0 plus 445 are referenced from a zero level that will be marked on the site. This zero level is shown on a section drawing. On my drawing, I will pan to it now. This is a section drawing and our zero level is shown here. As you can see, the ground floor level is at 0 plus 600, and this is our zero level. And you also note that the balcony and the staircase floor level is lower than the ground floor level. This level is 0 plus 445. The zero level is shown here on the section drawing. Typically, the zero level denotes the natural ground level on the site. So from this level to the ground floor is 600 mm, while from this level to the ground floor here is 445 mm. I will pan back to my ground floor drawing now. So we have the 0 plus 600 elevation label and the 0 plus 445. What does this elevation label mean? It means that this whole area is at 600 mm elevation, while the staircase area here and the staircase area here plus the balcony are at 445. So it means that the level at this area, the concrete lab, soil laboratory, and the lecture room is 600. Here is 445. So the elevation difference is 115. So if you want to enter this concrete laboratory, let's say from this door, it means that you have to raise your leg up, like to climb a staircase, 115. Now we have come to the end of this tutorial. In our next tutorial, we will look at section drawing on architectural projects.